Hello, my name is Akash and I will be demonstrating the code for the group assignment for my group number 8. So from our project we have built the data discretization algorithm, the semi-optimal cut algorithm into one single file. So to run this file, we don't need any specific arguments or input file location. We just need to go with the simple python sorry yeah python and the file name discrete.py, and we don't need to specify any input file location because the code itself asks for an input file location. So now our input file is actually the data.txt. So my actual file location should have been the whole C users Akash UNCCKDD project RSCS data discretization, then data.txt. Since my Python file and the input file is in the same folder, I can just write data.txt. Then it asks for the output file location. For lesser confusion, I'll like to store my output file in the same folder. So I'll just give the name of the output file. Let's say discretized underscore data underscore cs sorry dot csv. So now our code has ran successfully, and it has written the discretized data in this file. So first of all, let's see what other output we have got. First, we get discretized object instantiated. So I'll talk about this later. First of all, it will take reading data from the data.txt. So the data is being read from the input file which we provided here, and as we can see, the whole data has been printed in somewhat kind of tabular form. So here we have attributes 0, 1 and 2. Then starting the transformation. So since we have used semi-optimal cut algorithm, first the cuts will be generated, and later on the data will be transformed into a discretized data format using those cuts. So as we can see here, optimal cut number 1 for column 0. So column 0 can be optimally cut using 1.15 as my first cut. Then the second cut is on column 1 at 1.5. Then cut number 3 on column 1 for 2.5. Then these are the only cuts that are possible. So then it jumps to transforming data frame. In transforming data frame, we can see discretized data. So the output is such that we also get the output in the terminal, and we can also view that output in our discretized underscore data.csv since we gave our output file location. This is the discretized data, and then the transformation complete message, and then we are writing the data in the correct output file. Now let's jump to the code logic. Okay. So first of all, we are importing all the libraries and supporting libraries and functions from mentioned libraries and functions. The the main uh, the main code here is mostly in the class discretize. The whole class is built such that we can use it to discretize any kind of CSV data which has numerical columns, mostly numerical columns. Then let's see the input and the output file location as we discussed in the running part. Then we initialize d equal to discretize with discretize class. So first of all, the constructor will be called. So that's the reason we get this output discretize object instantiated. So in this part only these member variables are instantiated, and they are instantiated either to a empty list or a none value. Okay, then we then we use dot read function from our discretize class. So what does read function do is it takes in the path variable, the input path variable, file path variable, then it starts converting it into a data frame, and then it also initializes everything else, the other member variables to their initial point. Suppose if someone wants to again use the same, this has been done because if a person want to rerun the read function, the previous data should be deleted. So these are initialized to the uh, empty list and empty dictionary format. Then the second command is d dot transform. So transform function will be called, and transform function calls the private functions generate cuts and transform underscore df. Let's jump to generate underscore cuts. So here, first of all, we are separating the attribute columns other than the decision columns. Here we are considering the last column is always the decision column or the class column, which that data is being used. So in our input, we are defining these classes as 0 and 1. Okay. The third column is our uh, decision column. The rest other columns are attribute columns. So we are storing them into attributes and decision variable. Then since the read function is only reading the values as string, we have to convert them into float variable so that we can do all the manipulations that we need in semi-optimal cut. So this part represents that part, that converting the string into float. Then yeah, since in semi-optimal cuts we have to pair those records, those indexes whose decision value are not same. For example, in our data.txt file, we have 1 0. So it will pair all the 1 and 0 rows one by one. So this part represents making those pairs. Then let's come to this part. This part is used to identify the cuts which we can use, and we can find out optimal cuts out of the attribute columns. So these basically generates the average value between the unique values. So first of all, unique value from a single attribute is generated and sorted out in ascending order. Then one by one, the cuts are being stored in the one by one cuts are generated uh, by taking an average of the sorted list values. Okay. Then here we generate rows and columns, which we saw in our presentation, that we need to build a table. But here we are not building a table, rather we are building two dictionaries, rows and columns, which will be useful for identifying the optimal cuts. Then this part is to generate the whole initial table, uh, the step one in our semi-optimal cut algorithm. So here it takes each of the pair which are generated in this code. So each pair is followed by each each attribute's cuts. So it will find out. So, for example, in the presentation, we saw that every P1, P2, P3 are assigned 1 on the basis of finding the number of uh, cuts being present between two values of a paired row in that attribute. So this code represents finding out those for the whole table of ones and zeros. Then this part of the code is the combination of all the three steps: step 2, step 3, step 4 in the presentation which we mentioned. So this is the first part. This is the step 2, where we count the column values for each cut, and we get an optimal cut by sorting out them on the basis of their counts. Then we find out the discerned rows. Discerned rows are the rows which have the value 1 in the table which we have shown in the presentation in the similar way. Then we try to delete those rows from our table, and also and then we also delete the cut from our table. Okay. Also the output which we saw in the terminal is being printed here. Okay. Then after the whole table is being empty, this part of the code stops, and it jumps out of the while loop, and then it tries to, and then each of the attributes final cuts are stored in the final cuts dictionary, and every dictionary has a list. So this list of cuts need to be sorted, so that it will be beneficial for us in transforming the data frame. Then after generate underscore cuts, transform underscore df is executed. So here this is also a private function. This function just simply converts those attributes whose cuts are being generated into categorical variables. So numerical to categorical variables, so that they become more compact and we can use them easily for our model building for any machine learning model or any model which we want to build. So first of all, from final cuts, cut, uh, each attribute has a list of cuts. So we have to append minus infinity at the start of that sorted list, and a positive infinity at the end of that sorted list. So these two appending values is to uh, generalize the cuts. So this line of code basically tries to replace all the values that fall under those two values. For example, suppose for zeroth attribute we get 0.9 and 1.5 as our cuts. So a minus infinity will be appended before 0.9, and a positive infinity will be appended after 1.5. So we want all the values to be subjected to minus infinity to 0.9, which fall between these two values. Okay, and we mark them as minus infinity to 0.9. Similarly, all other attributes are uh, transformed in such a manner. Then transformation is done, transformation complete. Then we go to write function, which takes output file location as the parameter. Then in write function, we simply convert our data frame into another data frame, and then save it into a CSV file at the mentioned path. This is the whole code. Now let's go to the output file. So output file is already in the same folder. We can see here the cuts generated. Let's go back to the output. Yeah, sorry. Okay, so in the output we saw for attribute 0 we had cut as 1.5, and for attribute 2 we had 1.5 and 2.5. So according to my explanation, 0.8 falls between minus infinity to 1.15. Thus this value has been replaced by a string saying minus infinity comma 1.15. Then similarly the value 1 falls between this two range, thus it has been replaced by this. Then 1.3 exceeds 1.15, thus the value has been replaced with 1.15 comma infinity, positive infinity. So yeah, that's all for our code demo for our group project. Thank you.